Now, in introduction to algorithms, let us see master theorem. What is master theorem? First, let us have some preface. When we are analyzing algorithm, let us recall we are only worried about asymptotic behavior. Recursive algorithms, they are no different. Again, we have to find the asymptotic behavior also. So rather than just solving exactly the recurrence relationship associated with the cost of an algorithm, it may be sometimes sufficient to give an asymptotic characterization. How we are going to do this? We'll do this using master theorem. It is quite simple, easy. We have seen the recursion tree, how we have placed, say n by b, again n by b square, n by b to the power n, and then taken log values, compared log values, taken the height of the tree, and thus just place the value. So this master theorem has come up from there only. It's quite easy to understand that this Tn, if it is a monotonically increasing function, we'll see where it is not. So monotonically increasing function which should satisfy that Tn should be a t, and which is the function of n by b plus fn. And for 1, n equal to 1, it has to be some constant c. Here a is this value which should be greater than 1, b is this value, a is this, and b is this. B should be greater than or equal to 2, and what about c? C is greater than 0. So now if fn is of order n to the power d, if fn, we will find out this function fn in some example, and then we see that if it is of order n to the power d, so this is d. So we'll be comparing a, b and d. A, b and d. How? If a is less than b to the power d, we'll find a, b and d, and then we'll place, or we'll find out b to the power d, and then we'll try to find out whether a is less than b to the power d, equal to or greater than. If a is less than b to the power d, then we'll simply write that this Tn is of the order of n to the power d. If they are equal, then we'll say it is of the order n to the power d log n. Otherwise, if a is greater than b to the power d, master theorem says that Tn would be of the order of n to the power log a, and log is of base b. But you cannot use the master theorem if t is not monotonically increasing, that is not monotone, that is Tn equal to some say sin x or cos x. Fn is what? Fn is not a polynomial. If Fn is not a polynomial, then you cannot use it. If this is not a polynomial, you cannot find out the value of d from here. So you cannot apply here. And if b cannot be expressed as a constant, b cannot be expressed as a constant in this case, because b really we need a, b and d. Here we need a and b, d, these three values to find out which running time suits our Tn. So let us take an example. If you are you have not understood just by now, I hope that this example is going to explain it in a better way. If Tn is equal to Tn by 2 plus half n square plus n, so what is a? This is 1. What is b? This is b, 2. What is d? If this is our function fn, this whole is. So n square plus n, highest power is n square, so we'll take this 2 as order of nd, n to the power d, so we'll take d as 2. Now let us find out a and b to the power d. What is a? A is 1. What is b to the power d? B is 2 and d is 2 to the power 2. So it is actually 1 which is less than 4. So case 1 will apply. Case 1. And we know in case 1, by case 1, what would be the answer? The case 1 is n to the power d. Simply we'll write this. What will be the answer? This will simply be order of n to the power d, and we know d is what? 2. We replace d as 2 order of n square. Quite simple. Let us take the second case. Now this is our fn, and root n is what? N to the power half. And what is this half? This is our d. So a is 2, b is 4, and d is half. So 2, 4, half. Let us compare a with b to the power d, and we see that this is 2 and 4 to the power half, that is root 4, is nothing but our 2. 2 equal to 2. So we simply apply this case 2, which is nothing but Tn is the order of n to the power d log n. What is d? N to the power half is root n, and log n we'll write here. So this is simply log n root n. So let us take third case. In this we have function fn as this value. What is a? This is 3. What is b? This is 2. What is our d? This is n to the power 1. So we'll take it as 1. Now compare 3 and 2 to the power 1, that is a and b to the power d. We see that 3 is greater than now. So 3 is greater than 2. We apply the third version. That is the order of n to the power log a, which is of base b. So simply n to the power log. What is b? 2. And what is a? It is 3. So simple. These three cases are done. I hope you understood master theorem. But there is one more thing I would like to tell you. There is fourth condition also. So we cannot use master theorem if this function fn is not a polynomial, the non-recursive cause, that is not a polynomial. So there is a limited fourth condition of the master theorem that allow us to consider polylogarithmic functions also. What are these polylogarithmic functions? So if fn is of the order n to the power log ba log to the power kn for say some k which is greater than or equal to 0. If this is the form, we'll see an example, don't worry about this. If fn is of order this, then tn would be simply of order n to the power log b. We add log k with a 1 log and then n. So this final condition is quite limited and we just present it for the sake of completeness, but we'll take an example also. So we have a recurrence relationship of this form 2 tn by 2 and we have this polylogarithmic function n log n. We have a as 2, b as 2, but function fn is not a polynomial. But we have this function as order of n log n and we know that this is just 1 log to the power 1, so k equal to 1. So by fourth condition of master theorem, what we can say, if tn is of order n to the power log ba log k plus 1 n, simply we'll place these value. So n is this, our b is 2, a is 2, log, and what was k? K was 1, so add 1 to k, that is we made it 2 log to the power 2n. So this is ultimately order of n log square n. This is the fourth very limited condition, but for the sake of completeness we have to experience it here. So thank you so much. Hope you understood this master theorem. This is very important. This comes in various exams, specifically in GATE exams. Thank you so much.